Hello everybody, on behalf of the UVA training department, this is the FRA training video. We're going to fly a complete FRA from start to finish utilizing common 737 procedures. As I go along through the FRA, I will be explaining certain commonly missed items during certain phases, and also discussing certain commonly missed procedures and or phases of flight. There's also going to be some assumptions that due to flight simulator limitations, we cannot simulate per the real world, but there's still a procedure that we would like to expose the pilot group to. So without further ado, we will begin. Right now, per the FRA, we start with a cold and dark airplane, and then you start a complete put power onto the jet, safety check if you will, and then a pre-flight and so on. Let's get down to making sure that the aircraft is safe for power. So we're going to turn on the battery. Make sure we have above 23 volts. We have 24 volts. It's good. Look down here at the landing gear. It is down. We have 3 green. We're going to assume that the radar is off, which it's in test. Should be in test. And then, of course, in the EFIS panel, you do not have the jet's not powered, but you don't have the weather radar selected. And then also the parking brake is set. Alright, so the airplane is definitely safe for power. Come up here. Ground power is already established. Go ahead and connect that. And now just start to get the airplane ready for just a normal pre-flight setup. Okay, back to first pilot that enters the cockpit. Once power has been established, you also come up here to the upper overhead panel and align the IRSs. And while you're up here, you go ahead and pre-flight the upper overhead panel. I'm not going to go through all the pre-flight items. That would extend the video, and I think that's beyond the scope of the video. However, I will go over and discuss flows and or I'll just go over flows and make sure that we cover the flows per each phase. So right now I'm just starting the pre-flight flow. Real world, those would test. However, I believe in PMDG you have to have the hydraulics pressurized, but don't quote me. Alright, we've got the overhead, we've got the IRS is selected to nav. We've done the upper overhead panel pre-flight check. When I get to the crew oxygen gauge, it's my reminder that my next thing that I will do is when I get into the cockpit is actually I grab the logbook, put it on the dash so I don't forget to review it. I come down to the comm panel. Some 737s, the comm panel is on the left side, just underneath the oxygen mask. Sometimes it's on the center console. PMDG, it's on the center console. And I'm going to select the audio panel so that I can hear the ground guys to let me know when they're ready for pull-in external power, conditioned air, or they're ready for pushback. And I don't hear ATC constantly. Then I come over here and I'll test my oxygen. Real world, you test both the test button and the red button at the same time. When I'm doing that, as I'm pushing these buttons down, I look up to the upper overhead panel and I make sure that there's not a drop in oxygen PSI of greater than 100 PSI, and make sure that I have enough oxygen for the crew member, pilots, and or jump seat on board. Alright. Now, get in here and we would initialize ACARS. Obviously for this, there is no initializing ACARS. However, I am going to set up the payload and fuel per the FRA requirements. I've decided that per the FRA, your payload needs to be greater than 50%. I'm just going to go with 75%. And then fuel is, I'm just going to go with 16,000 pounds. Okay. After we've initialized ACARS, go up to FMC, and we want to insert and set the IRS position. Some companies have you put in a reference airport so that when you do select a GPS position, you can compare the airport GPS position to your GPS position. Okay, once we've initialized the ACARS, real world, and then now we've got the IRS is cooking, it's time to go do our pre-flight. Let me make sure that I'm ready for the pre-flight. Set the Alright, I'm ready for my pre-flight. Walked around the airplane and now I'm back in. Alright. And then now I'll go through my pre-flight flow. This is where 737 operators definitely vary. At a leading 737 operator, captain owns the overhead panel and then the captain's side. So I'm just going to go over and do my flow for the pre-flight, for the captain pre-flight. And I will also include the FO pre-flight, I'll let you know. Of note, I am leaving the hydraulic pumps, the engine number 1 and number 2 pumps on, and the electric 2 and 1 pumps off. That is a change to the UVA procedures. Alright, so after I'm done with the overhead panel, come down and start with the EFIS panel. I prefer the flight path vector on. That's definitely at the pilot's discretion. Oops. Flight director on the side of the pilot that's going to fly, so the master's on the side of the pilot flying side. And you can see the master's on the captain's side, MA here. I'm going to go ahead and pre-flight the MCP panel for what I know we're going to be doing. And while I'm here, since I've got to do the first officers, same thing. After that, come down here, captain tests the lights, sets it either bright or dim. Come through here, making sure the clock's on UTC, not in manual. Making sure the switches are where you'd like them. You can extend the air if you'd like. Go ahead and set up the captain's VHF and nav panel. We're at Dulles. There's ground. And for 19 left, there's tower. I'm going to select the Armel VOR. And then I'll have the ILS in standby. Since it is a short flight, I'm going to be doing some things on the ground before we leave the gate in preparation for the approach. I'll give us a fake transponder code, not a huge deal. Okay. Now basically the captain's pre-flight's complete. Of note, this is minor, but I didn't do it because it was already set up, but some carriers leave the standby attitude indicator in the approach mode, even for pre-flight. We'll go to the FO side.
Glideslope. Pull up. Wind shear. Wind shear. Wind shear. Terrain.
Of note, we'll do the JIP-WIZ test once the IRSs have aligned. Same with the weather radar test and the flight instrument tests. Also, the TCAS test. All of those require full IRS alignment. You'll know, especially with the TCAS, that you don't have a full IRS alignment, excuse me, because when you go to test, if your IRSs are not aligned, you'll get a TCAS system failed as opposed to pass. Now, this is not how certain radars are set up. However, I am going to hopefully perform the weather radar test correctly here. Oops.
Monitor radar display. Go around. Wind shear ahead.
The radar,
Wind shear ahead.
predictive wind shear and the radar test is done when you get a full display of the multicolor weather test. All right. So it's good. Deselect the weather radar test, or weather radar, excuse me. And we'll continue the flow.
TCAS test. Pass.
Okay, rudder should be working. I think it is. We'll call that complete. We tried it. Good, so the pre-flight is complete. Pre-flight flow, I should say. It's complete for the captain and first officer. Now, pilot flying will be setting up the FMC. Most carriers, you get uplinked at least your route. Some your perf and net. We're obviously going to manually enter the information. Per the FRA rules, must take off from 19 left. Basically, you're flying a pattern around and then back for the ILS 19 left. I'm going to set up for a reduced takeoff. Don't quote me on the slope, but I'm just going to put in 0. Certain operators, their Excel altitude is 800 feet. UVA is 1,000. So I will use 1,000 for today's purposes. And there is no special engine out procedure, at least for the FRA and for today's purposes. So we will use an engine out Excel height of 1,000 feet as well. No takeoff 1 derate, so takeoff derate with a reduced temperature. Also down here, RTO matches what we have selected in the N1. And then also make sure you're, at least for me and for most operators, no climb 1 or climb 2 options, just climb. Note, if you're using PMDG or an advanced FMC, note your V speeds. So when V1, VR, and V2, those are considered V speeds. So I'm writing those down: 136, 138, and 146. Also note the flap setting for takeoff. Decided to use very common flaps setting for takeoff is flaps 5. And once you've done that, there's two things you're going to take from this first page. Is well, there's a couple, but first you're going to make sure you see the reduced N1, so 95.6 on, of course, both engine number 1 and number 2. Your CG, so you get your trim setting, and then your V speeds. Come down here and you've got 146 in your V2. Let's set that in our speed window on the MCP. PMDG automatically calculates V2 plus 20 for you. Real world, just a gee whiz, you would have to set 146 in the MCP speed window, and then it would schedule or automatically schedule V2 plus 20 in the climb page for you. While we're here, this will remind me that I need to set up for my NADP2 climb profile. So once we do get to Excel height, at acceleration height, accelerate to your clean maneuvering speed. Most operators use VREF 40 plus 80. So in this case, it would be 211 up to 3,000 feet AFE. So I'm just going to go 3,300 feet. I'm going to set that here in my speed restriction, so L3, and then we want it to not accelerate to 291 below 10,000 feet, so I'm going to put 250 in L2. Hit execute. Alright, and that's my reminder that I can arm up VNAV. Let me zoom out. Alright, and then because I have populated an outside air temperature in the N1 limit page, you can arm up the auto throttles here. Alright, I believe we have most of the FMC programmed, so I'm going to start from the top left button here, the ident page, and verify that I've entered everything in the FMC correctly. Correct model, correct dates, the position initial init page, excuse me. It's good. We're out. We're going from Dulles to Dulles. We're taking off from 19 left. It'll be vectors to ILS 19 left. Takeoff page, flaps 5, reduced takeoff of 40 degrees. It'll give me 95.6% trim of 4.5. We'll get that here. Actually, I'll do that right now while I'm thinking about it. Close enough. And then our V speeds are selected. We've got 146 in the speed window. Let me take a look at takeoff page 2. That's populated, and we have 1,000 feet for our Excel heights. Good. Now, I've done the 6 right method to verify all the pages Once I'm done with being able to select something on 6 right, and then start with route. Again, this is all technique, guys. And good. I go to climb. I've got my L3 climb selected. Cruise altitude 6,000 feet. I'm going to select 250 knots. And then for the descent, 0.453, 250, 240 knots below 10. So good. Okay. Take a look at my legs page. That looks good. Altitudes look good. Okay. And then prog page at the very end. I would check distance on the flight plan. Obviously this is a little different since we're coming back to the same airport, but check the distance on the flight plan and then verify that your fuel remaining at destination matches your flight plan. Alright, so the FMC is programmed. Alright, before I brief, go ahead and get the APU going so that can be starting while we're briefing. And then now we will assume that we have our charts out, we've received our clearance, we've done all the pre-flight setups, or setup requirements, and the first officer and the captain are ready to brief. Briefing is very company specific. There are examples online, there's examples on the website. There are plenty of ways to brief. I'm going to use a very generic card to brief, and I will skip some items that are not pertinent in the flight sim world. So for the first departure brief, most carriers, the captain will brief his or her expectations first, and then the pilot flying will discuss what their how they will execute, what their plan is, and what the flight plan is basically for that flight. So starting with the captain stuff, they usually verify that both pilots are fit for duty. All of the cell phones and electronic devices are in airplane mode or turned off. We talk about pilot duties and currency, so who's going to be pilot flying, who's going to be pilot monitoring, and then in the event of a non-normal, who is going to react accordingly. I'm keeping some of these very generic again because this is a generic brief per the company, and in the flight sim world it is tough to replicate everything accurately. So after you talk about pilot duties and currencies, current and correct pubs, release verification of the flight plan, so making sure that you have the most current release. Fuel plan, for today's purposes, we have enough to where we can take off, land below maximum landing weight for a 737-800, and we still land with 2 hours of endurance fuel per the FRA requirements. So I planned on 16,000 pounds, and we have 16,000 pounds on board. No alternate required either. Maintenance status is good. It's a completely clean and no MELs on the logbook, or in the logbook. No NOTAMs or company-specific bulletins to speak of or that affect the flight. Taxi plan, we're going to push with ramp from Charlie 1. We'll go tail west, and then we will taxi straight ahead. Obviously with the ground, but not for today's purposes, but we'll taxi straight out on a single engine first. Once we turn left onto Kilo, we'll start the remaining motor, which will be number 1 in this case, and then we'll hold short of 19 left at Juliet 1. So we're going to taxi Kilo to Juliet 1, 19 left. No hotspots, and we reviewed the airport diagram. RTO and evac, a lot of captains will discuss the rejected takeoff and evac for today's purposes. I'm not going to discuss that. If we do have a problem, we'll just come back to Dulles, and we do not have a takeoff alternate. Now for the pilot flying stuff, we have a PDC and a clearance. It's just pattern work basically is what our clearance would say. Maintain 6,000 feet. Departure frequency is whatever the departure frequency is for this sector. Again, no ATC required in FRA, and we're squawking 2403. Departure review is the same. It's going to be straight out, heading, runway heading of 191 to 6,000 feet, and then it's a right turn to enter a box pattern and a right pattern for 19 left. It will be an NADP2 takeoff. Plan takeoff data, we've already reviewed that. It'll be flaps 5, reduced temp, and NADP2. It's a dry runway and calm winds. In the event of an engine failure, we're not going to discuss the entire procedure, but as a default, it'll be runway centerline to 1,500 feet before making any turns. My cockpit is set up. Will be standard displays and automation. I will turn on the autopilot above 1,200 feet per UVA SOPs, and then threats and mitigation is being videotaped. So slow down and make sure that we are adhering to SOPs correctly and not being distracted by trying to teach. You can come up with your own threats and mitigations if you'd like. A lot of those common ones are weather related, traffic related, fatigue related, etc. Great. So once the pre-flight brief is complete, then the captain will call for the pre-flight checklist. Again, using a very generic checklist. There's many ways you can. There's many types of checklists that you can use. Again, I'm using a common leading 737 operators checklist. So captain would call for pre-flight checklist. First officer would say pre-flight checklist and go through the items. Usually this is a challenge and response checklist. So I will say both the challenge and the response, but for the pre-flight, normally it's the first officer challenging and then the response coming from the captain. Pre-flight checklist. Pilot and flight attendant briefings complete. Flight deck windows closed and locked. Oxygen check set 100%. IRS selectors are nav. Pressurization is set auto. Auto throttles are armed. Altimeters and flight instruments 2992 inches set, and on the FO side set and checked. Speed brake lever down detent. Parking brake set, pressure normal. Engine start levers are cut off, and MRD gear pins are checked and on board. Pre-flight checklist is complete. I decided not to move the screen and look at every switch, but per many operators' SOPs, it is required that both the first officer and the captain visually confirm the switch position while the captain is responding to the checklist to make sure that the switch is in fact in the position that the checklist is calling for. But because I'm recording and we'd be bouncing all over the place, I didn't want to make everybody sick. But it is a very good habit pattern that when you are running through a checklist to respond to the checklist item while looking at the switch. Alright, so pre-flight checklist is complete. Now we are waiting for the gate agent to come up and tell us that the boarding is complete. So we'll assume that the gate agent just came up and said the boarding is complete. You just say, hey, you've got all of your required documents before they close the door, and then most people say check in with the flight attendant, lead flight attendant. Once that's complete, we can come up here. Oh, could have probably put on the APU. We can come up here, turn on the hydraulic pumps, and then could have done this earlier, but since the APU has been operating for 1 minute, nothing says it has to be on the buses for a minute, but it has to just be operating for a minute. Then you can introduce APU bleed air. Common error is when you put on the APU bleed air, you have your packs in auto, APU is on, but you leave the isolation valve in auto and you have split needles. In this configuration, the APU is only providing bleed air to the left pack, because with the ISO valve in auto, it's looking at the 4 corners, and if everything's in auto and on, the isolation valve will close. So it effectively puts a wall in the right here. So when the APU is providing bleed air, it's providing bleed air to the left pack, but then as soon as it gets to this wall, it stops. Hence the reason why the left needle is showing pressurization and the right needle is 0. So anytime you have split needles, make sure that you want split needles. In this case, we don't. So it's a reminder to go to open. Setting up this panel is very company specific. Certain operators, through training, do not have a problem with you operating with the dual bleed light on. However, that is very company specific. The SOPs that I'm familiar with, we do not have a problem with operating with the dual bleed light on as long as you understand the assumptions. With the dual bleed light on and the APU and the number 1 bleeds on, you cannot operate the number 1 engine greater than an idle power setting. Okay. Gate agent said boarding is complete, so they would probably close the door. The door is closed. Okay, we can also verify that all exterior doors are closed up here on our annunciator panel, the overhead panel. Then now we'll simulate that the flight attendant came up and said cabin is ready, and they close the cockpit door. So now we hear cabin is ready and all exterior doors are closed and locked. We can do the before push checklist. Captain makes his welcome announcement and then calls for the before push checklist, and that might be confusing. Captain does the before or the hello welcome announcement anytime. I'm not saying that that's part of the before push flow. Then turns on the seatbelt sign, and then when exterior doors are closed and locked and the cabin is ready, call for the before push flow. Before push checklist, excuse me. Now you do a flow. Before push checklist, seatbelt signs are on. Fuel, plan gate, 16.0, 16.0 on board. Fuel pumps, we have 4 on, cross feeds closed. Hydraulic pumps are checked and on. And doors, we already verified, were closed. Before push checklist is complete. Now you're waiting for the ground guys to tell you you're ready for push. Before I forget, I'm going to undock the jetway here. All right. Alrighty. Okay. Again, very SOP dependent. However, when we hear from the ground folks, they are ready for pushback, whatever the SOP comm is, we will say stand by, and then right before we call for push, we turn the transponder to transponder. Some major airports, as soon as you go to you select transponder on the transponder, it actually creates your aircraft symbol looks different, and it tells them that you are ready for push. So they might prioritize communicating with you over others that might be asking random questions. So before we call for push, we select transponder to transponder, and then we call ramp control. We'll simulate that we're calling ramp control right now, request push, and they approve it. And then since they've approved it, we come up here and we turn on the anti-collision light on. And then for today's purposes, I'm going to treat the logo light like the sterile light. So I'll turn the logo light on. And again, that's to simulate the sterile light. So once we've been cleared for push, anti-collision light on, the sterile light on. Now, again, I'm not going to use any type of pushback here, but real world, you would say brakes released, clear to push. And we'll simulate pushback. Given the specific airport, at their discretion, they have certain points during the pushback where they can allow an engine start, or some airports you have to be pushback complete. So it's very airport dependent on when you can start the engines during pushback. At Dulles, out of Charlie 1, you can start the engines during pushback. So I'm going to start the number 2 engine first, and we are going to taxi out on the number 2 engine. We do that because the number 2 engine, the number 2 bleed air, will then provide bleed air to the right pack, and the right pack provides cooling to the passenger cabin. Left pack provides cooling, or the left side of the air conditioning system, for lack of a better term, provides air to the cockpit. So we'll complete the push here. Parking brake is set, pressure is normal, and start number 2. Oops. I go to auto. You can leave it in open. It's fine. And now we're waiting for the into to get to 25%. Monitor for a hot start or a abnormal start. Waiting for the red limit line to jump up, basically go away, but it really jumps up to the idle. There we go. All right, come up here, and actually at one operator, once the engine or engines are stabilized, which today we're going out of single engine, so the engine is stabilized, and the tow truck operator has said disconnecting headset, which they're gone now. We'll simulate that they're gone. We can call for the flaps and then the after start checklist. So in this case, Captain would call flaps 5 after start checklist. Captain reaches up, turns on the generator, does a flight control check. Holds the tiller while you do the rudder, and the first officer will do their flow. For a single engine taxi, when you recall, so anytime you start an engine or before takeoff, we recall. You should have 3 lights. Air conditioning, because of the dual bleed. The hydraulic light, because the AA system is not powered. It is, but it isn't. And the electric. Alright, after the flow is complete, after start checklist, generator is on. Pro-Pete. I believe I forgot the Pro-Pete. This is why we have checklists. Yep. probe heat is on. Anti-ice is off. Recall has been checked. Auto brakes are RTO, and flight controls are checked. After start checklist is complete. All right, we call ground for taxi clearance. Ramp. Sorry, to get over to spot just short of the taxiway. Ramp says clear to taxi. And again, I'm not going to worry about manipulating the ATC frequencies because we're not simulating ATC today. I'm also used to using VR headset. I'm not using a VR headset today because it's very jittery. So I will call out when I would be clearing left, clearing right. We recommend you do the same. There is no AI in the FRA. There's no weather. There's no AI. So there's no potential for you hitting anything. But please maintain the habit pattern of clearing left and clearing right. It is a very busy place, simulation or real world. So ramp said go ahead and taxi. So I'd say clear left, clear right. I turn on the taxi light. Some operators require that. A forward-looking light before movement. And here we go. Real world, the auto throttle will not disconnect like this for a single engine taxi, but this is just a simulation. Simism, if you will. Start my clock here. Disregard. The sim takes a little bit more power than the actual airplane, so I'm keeping the power up, but you want to get the aircraft moving, power up initially, and then in turns power down as to not you don't want your exhaust blowing people over. Alright, FO would be calling for taxi. And we'll say the ground says taxi Kilo Juliet 1 to 19 left. And again, clear left, clear right. Anytime I'm making a turn. For passenger comfort, 10 to 15 knots is for ground speed. It's very comfortable for them. We don't want to exceed 10 knots in any turn. It is, again, very, it creates quite a moment for them in the back. Alright, we're on the parallel. And we're going to start the remaining motor. How you start that remaining motor, call for it, is company specific. Some just say delayed engine start. Captain would be taxiing. First officer is doing the engine start. First officer would announce being heads down, so the captain knows that he's not really getting any backup for the taxi. There's 25% in one thrust lever, or start lever, excuse me, up to idle. Doing a poor job of maintaining center line. That can be in the critique. There's the start switch cut out at 56%, and the red limit tick went away. Start my time for my 3-minute warm-up. We would have started it earlier. Started the engine earlier as well. With this short taxi, we probably would have 2-engine, but I wanted to show a single engine. And there's no traffic, so we can stop and wait for our warm-up. Or we can just call it warm-up complete since it is a simulator. So after the engine's stabilized, we'll do the flow. And ask the captain, clear to turn off the APU, yep. And recall's checked. And some companies do not have an after or a delayed engine start checklist. I do not. So it's just per the flow. Alright, so now it's, we've got about 2 more minutes. It's fine. This is a good taxi speed. And we can run our before takeoff checklist. Bottom line with the before takeoff checklist is you're verifying that your weights are correct in the FMC per your flight plan or per your planning software. Your takeoff speeds are correct. Flaps are in the correct position. Thrust is correct. Trim, and then again your FMC and then your MCP are programmed. Okay. So this before takeoff checklist says final weights are checked. Speeds, takeoff weights checked. Go over the V speed, stay set. Flaps are 5 indicated green light. Thrust is 4.8% reduced set. Trim is 4.500 set. FMC is 19 left. Vectors set. MCP 146, VNAV 191, 6000 set, and that's all good there. And then now we would call for final items. Tell the flight attendants please be seated for departure. Select TA. Start switches to continuous, and then recall. If it was icing conditions, you would turn on the anti-ice. And then if there was a bleeds off takeoff required, you would set up the pressurization panel there. Final items, departure announcements complete, takeoff configurations checked, air conditioning and pressurization set. Start switches are continuous, recalls been checked, transponder TARA. Before takeoff checklist is complete. And in 10 seconds we hit our warm-up time of 3 minutes. Alright, there's our warm-up time. .19 left. I saw the sign earlier. Obviously, real world, you can see it, but 19 left is verified. Sign there and on our nav display. Alright, so we have before takeoff checklist is complete. Runway is verified. That's required before crossing the threshold. Excuse me, the hold short line. Now we'll simulate that we contact tower. Tower says line up and wait, 19 left. Clear left, clear right, clear upwind. Whoop. Captains never do that. We do that all the time. Alright, we're lining up weight. I'm holding the brakes. And then we'll say tower. It says United 41. Glide runway heading, maintain 6,000. Runway 19 left, cleared for takeoff. And we read that back. Lights, clocks, fuel. Alright, here we go. Release the brakes, run it up to 40%. Make sure the engines come up symmetrically and they stabilize at 40%. They do. Looks good. As we're pushing it up through the vertical position, hit the toga button. Say check thrust. And thrust set 94.8%. 100 knots. V1, rotate. Positive rate, gear up. .400 feet, heading select. There it is. VNAV speed, heading select, throttle hold. Maintaining V2 plus 20. There's 1,000 feet. There's 1,200 feet. It's time to accelerate to clean maneuvering speed. Autopilot A is selected. We are accelerating. We're above accel height and above the white bug. I call for flaps 1. And if we're above the 1 bug now, I can call for flaps up after takeoff checklist. And notice the ref 40 plus 70 gave me my up bug on the more advanced simulators. Alright, after takeoff checklist, engine bleeds and packs are on and auto. Gear is off, lights out, flaps are up, lights out. After takeoff checklist is complete. So we're above 3,000 feet AFE now. We're accelerating to 250 knots and 6,000 feet. N1, heading select, VNAV speed. I'll wait until we turn crosswind and or downwind to set up for the approach. Alright, we'll turn crosswind. Big thing here is maintaining 6,000 feet, 250 knots, not to exceed 250 knots. And then now we're just making a right crosswind turn through a right pattern. It's a short flight, so recommend while the autopilot's on and you're on crosswind, you can go ahead and start setting up for the approach. I'm going to select auto brakes 3. We're going to use flaps 30. It's a default, no reason to use flaps 40. We're not doing an auto land, it's not a short runway, it's not contaminated. So I'm going to use flaps 30. My VREF is 147 knots. There's no wind out there, so my V target in my wind correction is 5 knots. So my VREF is 147, V target is 152. While I'm here, 110.1 is the ILS frequency for 19 left, which I'll verify here, and 191 is the course, which is set on the left side and right side. Okay, and 110.1 is set both left and right. The FRA recommends using the RML BOR radials, certain radials, for reference in the pattern, which you can set up on your fix page. Some of the radials it recommends using are the 175 and the 235. I'm not going to use those today, but I just wanted you guys to see how you set those up. Alright, I'm going to extend Dady. That'll give me some positional SA later on. We'll see. Alright, now I'm going to turn downwind. I like to give myself at least 10 miles lateral from the airport if I'm entering a downwind. Alright, so we build the approach in the box, which we did on the ground. We've got the ILS 19 left in there. I extended out to Dady. I'll probably give myself vectors inside of Dady but outside of Azumi. We set in our VREF flaps 30, 147, added 5 knots for as the minimum wind correction, so that's V target of 152. Set the throttle brakes to 3 as a default. You can select whatever you'd like given the runway condition and the runway length. And because there is no weather, we'll call the ATIS is calling again, must land 19 left, so they're calling 19 left and no wind, and 2992. So it's time for us to brief. We're below 10,000 feet. Most carriers would say, hey, FO or whoever is briefing, transfer aircraft control to the other person. So in this case, I would tell the FO to take over as pilot flying. I'd brief, we're in FMC speed, heading select and VNAV path. We're heading 010 6000, and if I'm still talking by the time we get to the beam, the airfield, let's slow to 210 knots. Alright, arrival briefing. FMC is programmed. ATIS is, as I just briefed, no NOTAMs or emails that are pertinent for this flight. Landing performance, auto brakes 3. We do have the required landing distance for our weight and our speed. Dry runway. The IMC, or excuse me, the ILS to 19 left. Recommend you use whatever chart you'd like for 19 left, but you verify the localizer frequency, the course selector, final approach fixed altitude, and what it basically briefs the briefing strip if you're using JEP, or brief the pertinent items. We will consider the ILS 19 left brief complete. It'll be a right-hand turnoff, and we're going to Charlie 1. Alright, no weather to speak of, and threats and mitigation is to, again, being videotaped. Alright, so I am coming up on Beam, the airport. I've completed my arrival brief. There's a checklist to run, however, we're going to fly the airplane first. So I need to slow the aircraft down. I'm still in VNAV, which is fine by me. You can be in altitude hold, whatever you'd like, but I'm going to stay in VNAV for now. So I'm going to open the speed window, and I'm going to slow to clean maneuvering speed, which is 210 knots. It's calm out there. It's not bouncy. We're in an 800, so I will slow all the way to the up bug without extending any flaps. But as soon as I go 1 knot below the up bug, I will need to extend flaps. Alright, so we're slowing. and I'll call for the descent checklist. Descent checklist. Pressurization was set. Recall. Oops, didn't do that. Recall has been checked. Landing distance and auto brakes checked. 3 set. Reference speeds, flaps 30, 147, 152 set. FMC and radios are set, and arrival briefing is complete. Descent checklist is complete. Alright, I'm slowing at 210 knots. I'm at 6,000 feet. I know that I'm going to get vectors inside of Dady, but outside of Izumi. That's 3,000 feet. So eventually I will need to start a descent here soon. Also of note, for my approach configuration and for my, well, basically my approach and my configuring points, I'm just going to configure to maintain stabilized approach criteria. So by 1,500 feet or the final approach fix, I'm going to be 180 knots. So in this airplane, it'll be probably roughly around at our weight, about flaps 5, 180 knots. By 1,000 feet, I will be in landing configuration and landing checklist complete. If I do not have anything, if I'm not complete, landing checklist complete by 1,000 feet, I have all the way to 500 feet to complete my landing items. If by 500 feet I have not had the landing checklist is not complete, I must go around. That is different from the UVA SOPs. It is recommended to configure at certain spots. So please adhere to the UVA configuration spots. However, most carriers now, most operators go with stabilized approach criteria, which is off of airport field elevation, so the height above the airport. I'm going to start a descent here. Retard, heading select, MCP speed. So, I extended Dady earlier so that when I am in a descent, it will give me accurate path deviation indications. So I'm going to expand this, and per the VNAV logic, I am 400 feet and increasingly descending greater from the path. So this is good. This tells me that I am managing my energy correctly. I'm not high, I'm actually low. So that way when I do turn to base leg and then turn a dog leg, I will be below the glide path, and I'll be able to capture the glide slope without having to dive and drive. So again, creating that stabilized approach. So I think I'm 1,000 feet below the path. That's a good time to turn my crosswind. Alright, and I'm going to slow to 180 knots, but before I do that, I'm going to go to flaps 5. Okay, 180 knots is above the flaps 5 bug, so that's good. I am configured appropriately. So again, utilizing all the available resources, my PDI says I'm 2,000 feet below the path. And again, VNAV always assumes you are on the magenta line inbound. So it's assuming that we are just outside Dady at 3,300 feet. So that's why it thinks we are 2,700 feet below. Ish. PMDG simulates VNAV fairly well, but again, I just know that I'm low on my vertical path, so energy-wise, I'm doing well. MCP speed, heading select, and altitude hold. About 2.5 miles from the magenta line is a good time to start your turn to your dogleg turn to intercept final. Going about 180 knots. We'll turn right to within 30 degrees of the runway. Right 160. I'm going to maintain 3,000. I'm just going to capture the glide slope at 3,000 and fly the glide slope down. We'll simulate that they said you're cleared for the approach. I'm going to arm the approach mode. And also when we are cleared for the approach, we do two things. One, you arm the approach mode. And then also we say ILS 19 left, 191. And if you have minimums in there, it's a visual day. Not required to put in minimums, but if you did put in minimums, you could put them here. And then you'd say them, and then our pilot monitoring says the altimeter, which is 2992 inches. And just to show you guys where the minimums go for today, for the ILS, for Cat 1, the minimums would be 502. If I know how to set them. There we go. Borlope captured. Glide slope's alive. Glide slope's captured. We set touchdown zone elevation, rounded up to the nearest 100. .2,000 feet. It's my technique. Gear down. Flaps 15. Once I put the gear down, I arm the speed brake. Slow down to flaps 15 bug. Flaps 25. And flaps 30, which is the final flap setting landing checklist. And we can select V target. And we can actually update that. VREF for 30 is now 146. We can say 151. Landing checklist. Slow. Landing checklist. Start switches are continuous. Speed brake is armed. Gears down. Flaps are 30. Green light. Landing checklist is complete. There's 1,000. Set missed approach altitude, and we will simulate that we are cleared to land. Missed approach altitude is 3,000. And this is pure technique. This is my... I turn the taxi light on and I'm clear to land. Alright, now don't make fun of my landing. I'm used to VR headsets. Or using my VR headset for landing. There's 500. I'm stable. I usually turn the autopilot off earlier, but because I'm talking and trying to train, decided to keep it on a little bit longer. If we were in the weather, we would say approaching minimums.
Approaching minimums.
PMDG does that for me.
Minimums.
And then minimums. Okay, I'm landing.
100. 50. 40. 30. 20. 10.
My centerline control is horrible today. Select max reverse. Fight for that centerline. There's 80 knots. Start coming out of reverse. Deselect the auto brakes. We'll roll to the next taxiway. High-speed taxiway. Notice I'm not deconfiguring at all while I'm on an active runway. Now I want to get distracted. I'm less than 60 knots to take the high speed. However, there's no other traffic. I'm going to take the reverse taxiway. Clear right, clear left. Once I am clear of the runway, okay, I can start to clean up the aircraft. Oops. Flaps are already up. 5, speed brakes in.
TCAS test. Pass.
we'll go back to Charlie 1. There is no after landing checklist, at least that I use, or the operator that I'm simulating uses. It's just a flow. But as you notice, I went from back of the center console and worked my way up to the overhead panel. While I run this straight ahead, I'll verify that I got everything on the overhead panel. Once you have your warm down time, or cool down time, cool down time, you can shut down and shut down an engine and single engine taxi in. Most operators will shut down engine number 2 because it's on the right side, and that's where the baggage compartments are, so that the baggage handlers can get to the bag, open up the baggage doors, cargo doors, and unload the baggage quickly. We contact ramp. Ramp cleared us in to Charlie 1. Alright, and a little late on the APU, but we usually start it when we see our gate sign. And then I'm going to shut down engine number 2 as well. We'll say it's been a 3-minute cooldown. Number 2 engine off, left pack off. So it provides maximum cooling to the right pack. And then, because I can't look left or right, I'm going to do this. Sorry about that. Oh, there we go. I need to turn in. Alright, before I turn in, let's turn off the nose light to not blind the guy or girl. Alright, we'll get sort of lined up on Charlie 1 here. Alright, so I have taxi light off. I think about 3 things when I'm pulling into the taxi spot. Taxi light off, engine number 2 off, and APU is on the buses. Alrighty, we'll say that he's marshalling us in, and then he tells us to slow down and stop. Parking brake is set, pressure is normal, shutting down engine number 1 because the APU is on, and then we immediately go into our parking flow. APU's been, we'll say the APU's been on for a minute. Operating for a minute. Again, logo light's the stereo light. We turn off all the electric or the fuel pumps as long as you're going to get ground power on within 5 minutes. Alright. Parking checklist. Parking brake is set. Pressure normal. Engine start levers are cut off. IRS selectors are off. Probe heat is auto. Anti-ice switches are off. Hydraulic system is set. Fuel pumps are off. Start switches are off. Beacon is off. Radar is off. Transponders in standby. And we will say that they hooked up power, ground air, and power. And we'll say they have conditioned air. APU bleeder switch is off, APU switch is off. Parking checklist is complete. And we'll do a complete shutdown, so we'll do a termination checklist. Before I do this, we would input something in, or we'd submit whatever we need to with ACARS. Alright, termination checklist. Emergency exit lights are off. Window heat is off. Packs are off. APU bleeder switch is off. External power is on. APU switch is off. Fuel pumps are off. And battery is off. Now this is how certain operators leave it. If you had maintenance guys come up, and since we'll do a complete go back to cold and dark for the FRA, we would just turn off ground power. And we have one blue light. Alright, that concludes the training video for the FRA. Thanks for your patience understanding some of the assumptions and some of the real-world SOPs versus the UVA SOPs. Please use this as a training aid backed up with the all the manuals that are in the pilot library, and feel free to contact anybody that is part of the UVA training department. Thank you.